Learning target 217 asks us to apply the value of numbers in a real-world situation. So we look at this one. A star's apparent magnitude measures how bright the star appears to a person on Earth. So apparent magnitude is what it looks like to us on Earth. A star's absolute magnitude measures its brightness if it were a distance of 33 light years, or about 194 trillion miles from Earth. So that kind of puts things more in perspective. Like if we were looking at the same distance from every star, how bright would it be? So absolute magnitude is the 33 light year distance. So if we look at this, letter A, it says order the stars in the table from brightest to dimmest when viewed from Earth. Then order the stars from brightest to dimmest if they were 33 light years from Earth. But keep in mind, the greater the magnitude, the dimmer the star. So it's kind of counterintuitive. The brightest stars are the biggest negatives. Okay, so when we talk about Earth, the brightest star, the biggest negative, is the sun. That makes sense. It's the one we see the brightest. So the sun is the brightest. And then if we think about putting these in order from least to greatest, maybe I'll do that with the decimals first. Negative 26.72, negative 1.46, negative 0.72, negative 0.04, 0.08, and then 0.46. Well, giving names, negative 26.72 was the sun, negative 1.46, that was Sirius, negative 0.72 is Canopus, negative 0.04 was Arcturus, 0.08, that was Capella, and 0.46, Achernar. I'm not sure if that's how you pronounce it, but we got it. And then if we talk about the 33 light year distance, as far as brightest to dimmest, again, brightest is the biggest negative. We'll put these in order from least to greatest. You've got negative 2.5, negative 1.3, 0.4, oops, there's a 0.2 in there, 0.2, 0.4, 1.4, and 4.8. So given names, negative 2.5 is Canopus, negative 1.3 is Achernar, 0.2 was Arcturus, 0.4 was Capella, 1.4 was Sirius, and 4.8, that was the sun. So even though the sun appears the brightest to us, it's because it's so close to us. If we compare it from a similar distance to all these other stars, it's actually the dimmest of all these stars. So there's our orders.